Howdy students, this is a video that's going to cover calorimetry, which is the measurement of heat change for a chemical and physical process. So what we're looking at is when we take one object and heat is lost by one object and picked up by another object. And what we're going to use is Q equals MCAT for both of these objects. And that is going to allow us to eventually calculate C for some sort of unknown substance. So what we're going to know is that the heat released by a system is going to equal the heat absorbed. And so as far as Q goes, if heat is released, that's going to be a negative value, and if heat is absorbed, Q is a positive value. The device we use is a calorimeter. It's an insulated device used to measure heat change in a chemical or physical process. So here's a picture of a calorimeter. It's just a styrofoam cup, and what we will do is introduce some sort of object, and the heat may radiate into the water. And from here we can measure a change in temperature, and we can use that in order to calculate the specific heat of that object. Another type is a bomb calorimeter. In a bomb calorimeter, we look at the burning of food, and from this we can actually determine food calories, which we see on food labels. So here's a picture of a bomb calorimeter. You would throw in food here. You would produce a flame, and the heat would radiate into the water. And then once again, you would have a delta T, a change in temperature. We're going to do one example of calorimetry. 25-gram sample of metal, and we do not know which metal this is at 75 degrees Celsius. It's placed in a calorimeter containing 25 grams of water at 20 degrees. The temperature stops changing at 29.4 degrees Celsius. What is the specific heat capacity of the metal? Okay, a couple things to note. This is a mass of our sample, and it's starting at 75 degrees. So this is not our change in temperature, but this is the T initial for the metal. And we have a mass of H2O, and we also have the T initial for the water. The temperature stops changing at 29.4 degrees Celsius. What is the specific heat of the metal? So let's talk through this. We're going to have to find the Q equals MCAT for the water first, and then we're going to have to find the Q equals MCAT for the metal. And what's important here is that the water is going to heat up. The metal is going to lose energy. So I'm going to draw a picture here. And this may help you with these problems. The water, we have a mass, 25 grams. Got some water in there. The temperature, initial, is 20 degrees Celsius. We also know the specific heat of H2O, which is either 4.18 joules per gram Celsius or 1.00 calories per gram Celsius. And then we have our metal. And the mass of the metal is 25 grams. The temperature initially is 75 degrees. And then I'm going to draw a final picture here. Water level will rise. We insert the cube into the water. And the only thing that we know now is that after a certain amount of time, our final temperature is resting at 29.4 degrees Celsius. So we can use this for both the metal and the water. Okay, so let's solve for the Q equals MCAT for water first. This is going to be the T final minus the T initial to get 9.4. You'll notice that's a positive value because energy is absorbed. For the metal, we can go ahead and do the same. And you'll notice that we get a negative value. Negative energy heat is released from the metal. So here is the heat absorbed by the water. We have the mass, specific heat for H2O, and the delta T. And when we solve, we get an answer here of 982.3 joules. Remember, this is positive. One thing to note is that the heat that is absorbed by the H2O is the same heat but opposite that is released by the metal. So what we're going to have to do here is actually flip the sign of this when we plug it in. So I'm going to take that and I'm going to plug it in for the Q, but it's negative. Here's the mass of the metal. We're looking, this is our X, and then we have our delta T for the metal. And when we solve for the specific heat of the metal, we get 0.86 joules per gram degrees Celsius. Now, we still don't know what the metal is, so we're going to take this value and actually compare it to a table of reference values. So 0.86 joules per gram Celsius, and we're going to look and see if we can match this up. So if I had to guess, 0.88 and 0.84. So perhaps, but these are both non-metals. The next closest metal is actually aluminum. So that would be my guess.